Hello everyone, and welcome back to the Deep Learning for Teens video series. In this video, I will show you how to implement an MNIST CNN in TensorFlow. In the previous video, I showed the main parts of a convolutional neural network. These include the convolution layers, pooling layers, flattened layers, and dense layers. In earlier videos, I showed how an artificial neural network can be built in TensorFlow to process MNIST images. In this video, I will add layers from the convolutional neural network into the earlier MNIST artificial neural network to build a CNN that can process MNIST images. We will first take an MNIST image and feed it into the first convolution layer. It will then go through pooling, convolution, and flatten layers. After the flatten layers, we send the output to the dense layers of the ANN we developed before. This means that the convolution, pooling, and flatten layers go between the input layer and the ANN dense layers. So, this is sort of what our MNIST CNN looks like. We first take the MNIST image and feed it into our convolution, pooling, and flatten layers. This is then sent to the dense layers. This is how we defined the MNIST ANN model in TensorFlow earlier. To convert it into a CNN, we add in the extra lines shown in red. These define two convolution and max pooling layers. I will now explain how the TensorFlow CNN model code works. This picture shows the structure of the network described by the code. The code in the red box is the first convolution layer, as you can see by the red box in the network picture. As you can see from the code, this network has 64 filters in the first layer. Kernel size equals 3 means that each filter is 3 by 3 pixels in size. The activation function for this layer is ReLU. Each MNIST image is 28 by 28 pixels, so our input shape is 28, 28. Since the MNIST images are also black and white, each pixel has only one value. This is why the input shape is described as 28, 28, 1. If these were color images, then the last number would be 3 instead of 1. The second layer is a pooling layer. We are using max pool, which means that we are taking the maximum value from each part of the image. Our pooling square size is 2 by 2 and our stride is 2. The third layer is another convolution layer. Here, there are 128 filters, and each filter is still 3 by 3 pixels. The fourth layer is another pooling layer. The fifth layer is a flatten layer. This is always needed between convolution or pooling and dense layers. The sixth layer is a dense layer with 128 neurons. The activation function here is ReLU. The final layer is a dense layer with 10 neurons, representing the 10 classes of digits in MNIST. In the next video, I'll show you how to run this code in Google Colab. I hope to see you then.